Hey everyone, if you work in cybersecurity, you've probably heard the name OpenClaw by now. Or maybe you heard it called ClawBot or Moltbot. Yes, it's actually changed names 3 times in about 2 weeks. And that should tell you something about how fast this thing has evolved. Today I want to walk you through what OpenClaw is, why it matters to security leaders, and what you should be doing about it right now. Just the facts and some practical guidance, so let's dive in. Okay, so let me start with the basics. OpenClaw is an open source AI personal assistant, but it's different from Siri or Alexa in some important ways. First, it runs locally on your own hardware. A Mac Mini, a VPS, or even a Raspberry Pi will handle this. Second, it connects to many of the messaging apps you already use. Things like WhatsApp, Slack, Telegram, Discord, Signal, iMessage. You talk to it or interact with it through those chat apps. Now third, and this is probably the most important part, it's agentic. That means it doesn't just answer questions, it takes autonomous actions. It can browse the web, schedule calendar entries, send emails, make purchases all on your behalf. And it has persistent memory that keeps track of all those interactions. It learns your preferences, your contacts, your projects, and it acts on that context autonomously. So let me tell you the backstory here. The project was created by somebody named Peter Steinberger. He is an Austrian developer who previously founded PSPDFKit, which is a PDF framework company. He sold that for a reported $116 million, and after that he got bored and started tinkering. So he launched this as a sort of personal experiment back in March 2024. A month later, it hit Hacker News and got 10,000 GitHub stars in about 48 hours. As of right now, it has over 158,000 stars, and that number continues to climb. So it's safe to say that this is no longer a niche or personal experiment anymore. Now, the naming history is actually pretty interesting. Steinberger originally called this ClawBot, and that was a play on Anthropic's Claude model. Then on January 27th, Anthropic's legal team sent a letter asking him to change it, or more appropriately, telling him to change it. So the community held a late-night Discord discussion and settled on the name Moltbot. The idea being that lobsters who have claws molt to grow. Now, when Steinberger went to rename the GitHub organization and Twitter handle, there was a brief gap between releasing the old handle and claiming the new one. And during that gap, crypto scammers grabbed the abandoned @ClawBot handle and they launched a fake Claude token on Solana. That token briefly hit a $16 million market cap, and then it crashed to zero. People demanded that Steinberger take responsibility for the speculative financial losses. It was a mess. The project renamed again to OpenClaw, which is the current name as of this recording. Let's see if this one sticks. Now that story is important because it illustrates how this project has evolved. The speed, the chaos, the immediate exploitation by bad actors, that's the pattern we keep seeing. The visibility of this project caused a rapid succession of growing pains for this team. All right, so let me get to the security side of things. Simon Willison, who is the researcher who coined the term prompt injection, calls it the lethal trifecta of AI agent vulnerabilities. And here's what he means by that. First of all, the agent has access to private data. It can read your emails, your messages, your documents, your credentials. And number two, the agent is exposed to untrusted content. So it processes input from websites, emails, documents, things you did not write. And number three, the agent can actually communicate externally. It can send messages, make purchases, and execute commands. So when you combine those 3 factors with persistent memory, you get an attack surface that is concerning, to put it mildly. So think about this for a second. A malicious payload doesn't actually need to execute immediately anymore. It can be fragmented across multiple inputs that look harmless individually, and then stored in the agent's long-term memory, and then assembled later into something dangerous. That's the time-shifted prompt injection. That's memory poisoning, and that's logic bomb style activation. So these are real attack problems, and they're all very plausible in this architecture. Now, just to be clear, this is not just theoretical, so let me give you a brief rundown on what we've actually seen in just the past few weeks. So there's a security firm by the name of Koi Security. They went through and audited all 2,857 skills in ClawHub. ClawHub is the public skill registry for OpenClaw. They found 341 malicious skills, and of those 341, 335 were traced back to a single coordinated campaign called Claw Havoc. Now, these malicious skills were installing a commodity info stealer called Atomic Stealer. Atomic Stealer can harvest browser credentials, keychain passwords, crypto wallets, and even SSH keys. And these malicious skills were disguised as legitimate tools, crypto trading utilities, YouTube summarizers. And ironically, some were disguised as auto updaters and security tools. But wait, there's more. OpenClaw has disclosed multiple high-severity vulnerabilities. One CVE enables one-click remote code execution. Another allows command injection through the MCP remote component. And just recently, a security researcher named Jameson O'Reilly searched Showdown for ClawBot control. He found hundreds of exposed instances. A number of them had no authentication at all, full command execution wide open to the internet. A bunch of them had working authentication, but they were still exposed to the internet, and the rest had partial exposure through misconfigured proxies or weak credentials. Then there was the Moltbook breach. Moltbook was the social network for AI agents. 1.5 million bots interacting with each other, and it was built on OpenClaw. 3 days after going viral, Wiz researchers discovered a misconfigured database. Exposed 1.5 million API authentication tokens, 35,000 email addresses, and private messages between agents. And to make things worse, OpenClaw stores everything as plain text. Memory files, VPN configurations, corporate credentials, API tokens, all of it sits as Markdown in JSON in a hidden folder in your home directory. So unlike browser stores or OS keychains, these files are readable by any process running as your user. Now, I try not to just pile on the doom and gloom, but the expert consensus on this one is pretty consistent. For example, Heather Adkins, the VP of Security Engineering at Google, is recommending against installing it. She cited researchers who described it as an infostealer disguised as an AI personal assistant. Gartner warned that OpenClaw comes with unacceptable security risk. Even OpenClaw's own documentation acknowledges it. They write, there is no perfectly secure setup. Now here's the thing that makes this hard for security leaders. OpenClaw is genuinely useful. People are not installing it because they're reckless. They're installing it because it helps them get their work done faster. And of course, there was a recent survey that found that employees will use AI tools that violate their company policy if it helps them finish their work faster. So if you just block OpenClaw without offering an alternative, you're going to drive adoption underground. And that, of course, is the shadow AI problem. This thing is useful, it's popular, and your employees have probably already seen it. And you probably already have some shadow usage already in your organization. All right, so let me give you some practical guidance. This week, there's a few things you should do immediately. First, discover if you have any existing deployments. Search your endpoint telemetry for these indicators. Process names like Moltbot, ClawdBot, or OpenClaw, directory paths in the home folders with those names, and network traffic on port 18,789, which is the default. Also, connections to Molt.bot, OpenClaw.ai, or ClawHub.io are all suspicious. Second, if you find deployments, assume credentials are already compromised. The plaintext storage means any prior malware infection could have already harvested API keys, OAuth tokens, and service credentials. Third, block ClawHub skills downloads. The skills repository has demonstrated weak vetting. Until the supply chain matures, treat third-party skills as untrusted code. Issue clear guidance to your organization. Acknowledge the productivity appeal. After all, these people are likely not trying to undermine you, they're just trying to get their work done. But you'll probably want to explain the risks plainly and provide an approved path forward, even if that path is just wait for the enterprise controls to come about. Now, over the next 30 days, here's what I would recommend. If there is genuine business demand, consider establishing a controlled pilot. Run OpenClaw in a hardened container, non-root user, read-only file system, dropped capabilities, restrict network access to only required domains, use dedicated API keys with minimal permissions, not your production credentials, and enable process isolation and monitoring. Prohibit connections to production data or high-value accounts, and you should also update your threat models and run a tabletop exercise to find gaps. So over the next 90 days, you probably should start thinking strategically. Develop an agentic AI policy. Which agent platforms are approved for evaluation versus production? What data classifications are never permitted in agent contexts? And what are the requirements for human oversight of agent actions? How will you handle incidents involving autonomous agent behavior? And if there's genuine demand, look at vendors with actual enterprise controls. All right, so let me leave you with 3 closing points. First, this is being adopted rapidly right now. FOMO is driving experimentation without acknowledgement of the risks involved. Second, the risks are not theoretical. Those malicious skills, RCE vulnerabilities, and exposed credentials, they all happen within weeks of widespread deployment and adoption. Third, blocking alone is not enough. You've got to provide a way, some legitimate pathway for legitimate use cases. Strictly prohibiting without alternatives just drives adoption underground. So let OpenClaw serve as a wake-up call. The organizations that build the frameworks now will be better positioned when the next viral agent arrives, and there will be a next one. Now, I've detailed in this my newsletter, the Product Security Playbook. I'll drop a link to the article in the notes below. I also have an article that will be published next week that dives into the OWASP Top 10 for agentic applications. So if you enjoyed this, please consider liking and subscribing so you're notified when the next one goes live. Thanks for watching. I'll see you in the next one.